Potential energy is thought energy. Objects may have potential energy in terms of their position. It is said that the amount of potential energy in an object is related to the height of the object from the ground. In relation to this, we designed an experiment to investigate the relationship between the height of the object and the potential energy involved. Number 1. Problem statement. How the increase in potential energy influence the distance traveled by the object. Number 2. A. To investigate the relationship between the height of the ramp and the distance traveled by the marble. Number 3. Hypothesis. If the height of the ramp increases, the distance traveled by the marble will also increase. 4. Variables. The manipulative variable is the height of the marble from the reference. The responding variable is the distance traveled by the marble. The constant variable is the size or mass of the marble. We are going to take the measurement related to distance and height in centimeters.
Fifth, materials and apparatus. The materials and apparatus we use in this experiment is a measuring tape, a masking tape, a thread, a marble, a ruler, a wire casing, a box cutter, a pair of safety gloves, and a calculator.
6. Procedure and method. First, gather all the materials. Second, combine the wire casing and make it a blank. Measure and mark the height 2, 4, 6, 8, 10 centimeter. Make a hole and mark point. Insert the wire casing at 2 cm height. Release the marble from the top of the blank. Measure the distance traveled by the marble using measuring tape and thread. Read and record the distance traveled by the marble in the table. Increase the height of the blank and repeat steps 6 to 8. Attempt the experiment 5 times in each side. Number 7. Safety precautions. We must wear safety gloves while conducting the experiment. We also must be careful while using the box cutter to cut holes in the box and make plastic cuts. Now we are going to demonstrate the experiment. Ready?
Ready.
1, 2, going to change the ramp to the last height, which is 10 cm. Ready?
Ready.
1, 2, 3, 4.
Three 317.8. Before the recording, we did 4 attempts in each height. We did 4 attempts in each height. We also calculated the total distance and average distance in each height.
Number 8, observation and result. At 2 cm height, attempt 1, the distance traveled by the marble is 99.0 cm. Attempt 2, 95.4 cm. Attempt 3, 98.2 cm. Attempt 4, 96.0 cm. Lastly, attempt 5, 110.0 centimeters. The total distance the marble travels is 498.6 centimeters and the average distance is 99.7 centimeters. The average distance at 4 cm height is 163.8 centimeters. The average distance at 6 cm height is 230.8 centimeters. The average distance at 8 cm height is 266.4 centimeters. Lastly, the average distance at 10 cm height is 327.7 centimeters. Following the table, we can see that when the marble is released at 2 cm height, the distance traveled by it is shorter than 10 cm height. We have converted the data from the table to a graph. We can see the increase in distance clearly in the graph. We can also see the increase in potential energy using the potential energy calculation. The SI unit to calculate potential energy is joules. The formula of potential energy is PE equals to M into G into H. M represents the mass of the marble, G represents gravitational acceleration, and H represents height of the object. At 2 cm height, the amount of potential energy is 0.0012 joules. 4 cm height, 0.0024 joules. 6 cm height, 0.0036 joules. 8 cm height, 0.0048 joules. Lastly, 10 cm height, 0.006 joules.
Number 9. Discussion and recommendation. Our discussion and recommendation is when the marble is released at 2 cm height, the range of distance traveled marble is between 0 to 150 centimeters. The average distance traveled marble at 2 cm height is 99.7 centimeters. Whereas when the marble is released at 10 cm height, the range of distance traveled marble is between 300 to 350 centimeters. The average distance traveled marble at 10 cm height is 327.7 centimeters. When the marble is released at 10 cm height, the distance traveled marble is longer compared to other subsequent heights.
David, is this our first and last product?
Of course not. We have conducted the experiment several times with different type of products.
Why do you use various quality of boxes?
Because when we use various quality of boxes, the hole is cut off by the screw, thus making the hole loose.
Pavira, why did we change the ramp several times?
It's not stable because the ramp is not strong due to the type of material.
Dinesh, why did we change the surface while conducting the experiment?
When we use tile floor, the marble goes uncontrollable. When we use stone floor, it gives the marble more friction. When we use LED light bulb, which is also a fluorescent light bulb, it is easily bent and not stable.
Smell. What affects the distance traveled marble while traveling through wooden surface?
We found out there is a mechanical error on our ramp due to the uneven surface at the joint point. To rectify this problem, we use sandpaper to smoothen the joint points. We also found human error at
at the releasing point. To rectify this problem, we use minimal force and cards to release the marble. Our first product was with thick A4 paper and books. Our second experiment was with cobra whip. We didn't use cobra whip because it was more onto elastical potential energy and we couldn't measure the distance because the sticks splattered. Our third experiment is with using fluorescent light box toy car with a height of 5, 10, 15, 20 and 25 centimeters. We didn't use marble because it goes too far and we do not have space to measure it. Our fourth experiment, we used fluorescent light box, a box and a marble. We did the experiment on the table. The paper surface was easily torn and not strong. Our fifth experiment, we used the same material when we changed the height from 5, 10, 15, 20, 25 to 2, 4, 6, 8 centimeter. We did the experiment on the table. This time, the distance traveled by the marble is not too far.
Our sixth experiment is using the same material on the ground, which is a tar floor. We did not use tar floor because it is very uneven and unstable. Our seventh experiment is using plywood, some chopsticks, 2 boxes, a marble on the table. Our eighth experiment is using the same material at the height of 3, 6, 9, 12 centimeters. When we released the marble at 9 cm height, the marble reached the maximum point, so we couldn't calculate the potential energy.
We did not use wooden chopsticks in our current experiment because it takes time to place the ramp on it and is unstable due to the quality of the box. Our ninth experiment is creating a slit at 2, 4, 6, 8, 10 centimeters. We did this experiment because the marble travels correctly and we can measure the distance covered marble. We did not use this experiment because it takes time to insert and remove the plank. Lastly, we used 2, 4, 6, 8, 10 centimeter height with a wire casing and a masking tape. This time, the marble travels correctly and we can measure the distance covered marble. We also invented an invention at the releasing point. We invented this invention to reduce the human force at the releasing point.
From the result, we can conclude that when the height of the object is increased, the distance traveled by the object also increases. So our hypothesis is proven. Objects from high rise have more potential energy. In conjunction to this, there are many real-life objects functioning based on potential energy such as roller coaster, elevator, hydraulic dam, and slide. The transformation of energy happening there is potential energy to kinetic energy. Potential energy is very important to us. Throughout this day, we conducted many experiments to testify the theory of potential energy. This is the logbook evidence for this. As a human being,